Welcome back, everyone, to one amazing talk that we're about to hear, I'm pretty sure, from Michael Smith, Design Manager at Ford. So without any further ado, Michael, welcome to the stage.
Hey, I'm unmuted. Hopefully you can hear me, and then I'll start my video here so you can see my fresh VR hair. How's it going?
Good, and you?
I'm doing well. Hope everybody's doing great today.
I'm sure. Well, I'll leave you to it, Michael. See you for the Q&A.
Well, okay, so let's, I guess we'll just jump in. I think Jaren's going to drive the Zoom coverage. And when I see that he's jumped in there, I will, I'll join him and start yapping. All right, Jaren, if you want to cycle through to the first viewpoint. Should bring you up to the can you do viewpoint 1 that says start here? Unless you're not seeing the same viewpoints, that would be trouble. Boom, awesome. All right, well, welcome everybody. I said my talk was about the human machine learning, and that's kind of a play on words. You know, we're all humans, and there's also something called machine learning. And I was attempting to be cheeky by combining those phraseologies. I guess I'd start off with, you know, what is the definition of a machine? And I think, you know, it's could be defined as a tool that uses energy for an intended purpose. And in my line of work, people who use their creative energy for designing mobility can be considered human car design machines. As a species, we're just about to start tackling the topics of artificial intelligence and machine learning. And that's resulted from this other machine that we've created as humans. You might have heard of, its computer, which we're all on today, most likely, some form of. This presentation will merge the topics of creativity and its origins in our evolutionary past, increased virtualization of our design tools, and how current events have accelerated this. The idea of a creativity equation and how things like artificial intelligence and machine learning can be optimized and integrated into our future workflows. And I think, you know, when I tried to come up with the idea for this talk, it was basically because time, right? I think it's time to reflect on how we got here and where we're going. I think a certain amount of this is to give high fives to the crew at Gravity Sketch. I didn't come up with all the concepts in this talk because I'm not, I'm not that smart. I'm going to paraphrase lots of people, and I did that. I'm doing that because there's not enough time in the day for me to research and become an expert on everything in this talk. But hey, we invented Google and the internet too, so I figured I might as well take advantage of that. And so I'm starting here with this idea of a clock, and then I'm going to turn that off and show you the next aspect of time here. You can go to the next one, Jaren, called timeline. And what this is trying to show you is this. I'm trying not to, if you want to grab that, Jaren, that to scale, well, when you unscale it, that's 1 foot in real life. And 1 foot equals 1,000 years on this timeline. And so you can see it stretching out almost to where you can't see it anymore. And that's sort of the beginning of Homo erectus, right? And so that entire gray line is the evolution until we get to this magical point, which you can go to in the next viewpoint. I'm trying to give you guys a sense of scale, right? And so there's an inflection point, and and it's at 200,000 years ago, and that basically is the research evidence suggests that interesting things were happening around 200,000 years ago with us, Homo sapiens. And that's because we were well on our way to evolving the biggest frontal cortex in proportion to the rest of our brain compared to other creatures. It gives us a really broad range of higher function. Creativity is a trait our ancestors evolved to overcome barriers to their survival. It helped, and you can sort of see this progression in the timeline, right? As we evolve along here, we're using that big brain to do lots of cool stuff like develop complex language, plan ahead, strategize, coordinate, invent tools, build shelters, treat wounds, right? Everything arising from, and everything involving creativity arising from this idea of solving problems. And so, hundreds of thousands of years later, our innate desire for creativity is still serving us well in advancing our technological and scientific and cultural prowess. Personal creativity improves the survival of entire societies, which feeds back to our individual survival. This is a biological mechanism for creativity embedded in our DNA. I think that's pretty sweet. So we should give ourselves a little bit of a hand clap for making it this far. And the next sort of point on the timeline is this sort of widely accepted example of creativity. And that's the cave paintings in Lascaux, and that was 30,000 years ago. And then the next point is 12,000 years ago when we started to do agriculture and make settlements. And again, I think what's, the reason why I'm being so nerdy, about all the rest of this stuff, in terms of a timeline, is because, is because I want to sort of give a sense of time, right? And the fact that we've been creative for a long time, but in the comparison to the overall, I think it's kind of tremendous how it's very much blink of the eye kind of stuff. And so between 12,000 and now, we've been doing lots of problem solving to get us to today. And I think here we are today. 10 years of time is represented by this little sliver of green, and that's 1/8 of an inch in true scale. And this is, again, me just being a little bit nerdy, using the true scale nature of Gravity Sketch to show off kind of stuff. I hope you guys noticed the well here next to the farm. My daughter was very picky about me putting the ropes in the bucket. She was very keen on that, and we designed the corn together. So that was fun. All right, so the next one, turn this back on and turn the timeline off. If we go to the viewpoint that's called consciousness, Sharon, we'll turn that one on. And there's something kind of unique that's happening here too, right? I'm going to take a quick detour into this because consciousness is a very interesting subject when you get into it in terms of creativity. This graphic or this 3D model is meant to sort of illustrate an idea, and that's that the research right now suggests that your consciousness doesn't reside in a single area in your brain, but rather it's how the brain talks to itself. And so if you thought of your experiences, your memories and emotions are towns and cities spread across a map of your brain, then consciousness is the interconnected network of roads, highways, and junctions that facilitate the movement between them. And I think it's really kind of fascinating because we definitely have creative, conscious thoughts. We use our imagination, we generate simulated data, we explore ideas, we make connections, we reach new conclusions. But there's definitely a carved out segment of creatives that credit true inspiration to the subconscious mind, which we all know is daydreaming. And I think this is where the roads of VR and creativity and the subconscious meet in this flow state that is basically an intentional 3D daydream. And if this environment and the way I'm presenting this comes off that way, it's because that's kind of how it came about. So let us now, we've arrived at the now on the timeline. And if you go to the next one, Jaron, there's one called 5 years ago. And basically, oh wait, I forgot to turn on, what happened to my stuff here? there's so much other cool stuff here that I wanted to make sure this. There we go. Cool stuff. I think I deleted my table. There was a table here. Anyway. All right, so 5 years ago, there's an ancient proverb that says necessity is the mother of invention. And at the time, the world had Tilt Brush, which is a great art tool. But what it needed was a great VR design tool. And thankfully, thankfully, we got this. And that was the video that sort of got me excited about Gravity Sketch. And the team brought it into existence. And, I think even though it took some time for me to convince my management at Ford that this up-and-coming app was, in fact, a big deal, it was very fun to expand the boundaries of the tool at Ford and introduce many of my coworkers to designing in VR. I don't need to go into all the ways that Gravity Sketch is great. You probably all have a good sense of that by now. And the special stuff I do want to talk about is one that actually Shay announced earlier today. In many ways, I still pinch myself. We at Ford were there in the early days of a feature called Co-Sketch. Now it's called Collab. And we're proud to have helped play some small role in helping to develop it. I don't need to go into it, but the unique advantages of making multiplayer design fun is where it's at. And it'll come to nobody's surprise that leveraging a collaborative design process has been explored in new ways over the previous 2 years, thanks to COVID, where work from home went from an idea of, hey, wouldn't that be cool, to basically after March 13th of 2019, we're working from home now, right? And so it was a big switch. Co-Sketch has been an amazing tool for this time to let us try new ways to work as well as being part of building the confidence that we can do more. So with this idea that we can do more, let's talk about the next 5 to 10 years and where we might be headed in terms of technology and innovation. I don't know if you guys have heard of this, but artificial intelligence, machine learning are coming. And the question always comes up with when I talk to designers, hey, should I be worried about the future? I have a guy on my team whose specialty is AI, and we get asked, are you trying to make computers take over our jobs? And the answer is no. And I don't think we need to be worried as long as we go into the future with the right intention, meaning understand where we are best positioned in this computational landscape and create new tools that enhance our ability to creatively solve problems without writing ourselves out of the creativity equation. And so if you've never heard of the creativity equation before, Jaron, you can go to the next viewpoint. And this is basically the product of Ruth Noller. She's a former professor of mathematics, and she developed this formula describing the factors that produce creative behaviors. And I'm not going to get really heavy into equations because I went into design so I could get away from math. What's important to understand is it's basically a function of 3 different variables, and that's K for knowledge, I for imagination, and E for evaluation. It's easy to remember, right? Knowledge is obtained through our life experiences. Imagination is one's ability to generate ideas and make connections, and evaluation is examining the advantages and disadvantages of a particular idea or situation. So let's evaluate where AI and machine learning are in relation to this creativity equation. And I'll say just right now, rest easy. Humans have a pretty good leg up on these technologies in all 3 categories. And so in terms of knowledge, we know computers have a really cool advantage in that they don't sleep and they love to learn new things. And we're busy doing that, right? Tasking computers to learn new stuff. I don't know if you knew this, but every time we do one of these CAPTCHAs, we're teaching some sort of AI somewhere how to recognize these things out of images, right? So traffic lights, buses, and crosswalks. It's kind of interesting that that's what this random sampling of CAPTCHAs found for me. But there's a big gap between things that we can feed computers and, a computer's insatiable desire to learn new things. I got this guy here who is always yelling how he needs more input. And I think that's pretty much the closest we've come, except for maybe some spot robots, of a robotic artificial intelligence that is going out and getting experiences in the real world. So I'm not really worried about competing with Johnny Five. This is how computers do things, right? This is an AI, a machine learning. It's actually a really cool game. While True, Do Learn. I play this with my kids, and essentially, it's a way to learn how machine learning works, and it's really kind of fascinating and fun. But this is sort of the visual analog, right, to how a computer learns. So we currently create AI models that are very dense, and that means they're really good at learning and doing some activity pretty well. So this one was, showing how to sort something. And I think it's by color and shape. As you can see, the different shaped objects and colors. But it's said that they're fully activated every time they're called upon. So when you ask an AI model to do something, it taps into the whole model all at once. And I just want you to sort of imagine a situation, right? If this is the equivalent of a human trying to choose what to wear on a particular day, and if you're an AI, it would be like being forced to recall and consider everything you've ever learned and understood about clothing in general, different types of cloth, different fashions, colors, textures, the manufacture of clothing, and every article of clothing you've ever worn or looked at. Well, that's, you would be able to get out the door in the morning. But humans, right, picking the outfit for the day, that requires only knowledge about clothing. You tap into a little bit of that, your awareness of the weather, your ability to imagine what the weather might be like, your mood, your schedule, and you make connections between all these things. It should come as no surprise, unfortunately, that computer scientists are working on, not unfortunate, it's cool. Computer scientists are working on a hybrid approach that combines several sparse AI models in order to generate faster and more thoughtful knowledge-based decisions, right? So it's not there yet, but they're definitely working on it. So the next one is imagination. And I think, again, I think we're in pretty good shape as humans in terms of this part of the creativity equation. For reasons that I'll get to in just a moment. But I will say right away, as a computer scientists are already hard at work on this one too. In May of 21, a paper was published entitled, and this is really chewy, Zero-Shot Synthesis with Group Supervised Learning. What a mouthful. I read into as much of that as I could of that paper. But when you dig into it, what you come to understand is what this team is researching is something called disentanglement. And disentanglement refers to a new style of machine learning that samples a group of images, not in the traditional way, which is this way, per pixel, right? So a computer would look at this image of a Bronco and literally just row by row, pixel by pixel, try and determine what that object is. That's the old way. The new way is to take a couple, many images and view them sort of step back almost in a way. So it samples the whole group of images and it tries to learn the similarities between them in the abstract. So it is allowing the algorithm to disentangle the attributes of the subject matter in the images from the image itself. So this one would say, the collection of pixels in this image is most likely a car. The new way says, well, based on the fact that these images all have wheels, fenders, hoods, and headlights, these are images of cars. And I would say the easiest example to give you that's more recognizable as an example of disentanglement would be a deepfake video. So, right, so machine learning has already been used to separate the attributes of a video, the person, their voice, the lighting, the movement of their head, mouth, etc., such that attributes can be swapped and frequently choose to put a different person's head in place of the original. But this operation in the abstract space versus the pixel space is what is novel and unique. And it is how that happens to be more human in its way of thinking. And I think there's a measure of inevitability here, right? So in the fact that AI doing a better job of disentanglement, thinking in the abstract, is really vital to the long-term success of things like autonomous vehicles. For that technology to work, we need machines that can think more like humans. It's just a fact. For reasons specific to our biology, humans can imagine themselves in situations they have never been. Training cars to drive themselves has been happening for quite some time. And for the most part, the easy parts of that training are easy. They're already done. What's difficult to train for is this stuff right here, your edge cases, your outliers. They're random by their very nature. And this really makes it impossible to state with 100% confidence that you've trained your car for 100% of all possible scenarios. What you need is a system that is always evaluating the situation and ready to learn more. I especially like this mini with inflatable duck on the top. I really, I mean, if you had to sort of ask a group of 100 creative people, what is the craziest thing you could imagine on top of a car? I guarantee you that's not coming up on day one. Well, guess what, though? This is a cool situation. This is how humans survive the process of learning to drive, because we're in the same boat, right? Faced with being at the top of a hill with an ice-covered road below, we have experiences we can draw from. Maybe it's a past experience of a similar situation. Maybe riding as a passenger in your parents' car before you're ever driving. Seeing videos of sliding cars on YouTube. Our brains can quickly paint an imaginary picture of things that could happen by driving down that hill. And this allows us to change our behaviors in the moment to compensate. The benefits for autonomous driving are significant because every time an AI driving model gains new experience, guess what? Every copy of your AI gets smarter instantly, or as soon as it's uploaded. And lastly, evaluation. So let me turn that one off and turn evaluation on. The power of evaluation begins with creating connections through learning. Understanding causal factors, right? Gaining knowledge about how the world works by acting in the world. So this image is meant to reflect on, consider how babies learn about basic physics through reinforcement learning. Baby says, I'm given a toy, let's it go. It will likely drop to the ground. As anybody who's ever interacted with a baby in this phase of development knows, eventually they learn to count on the object dropping and turn it into a game. The game is, how many times will this human pick this thing back up and give it to me? As a parent, you hope they will quickly learn to evaluate whether something is a good idea or not. Maybe I shouldn't drop this bowl of spaghetti on the floor. It again comes back to this idea of abstraction and being able to imagine the consequences of a certain choice. And so now we get to where we as humans have an advantage. So this one's called Advantage Human. Sharon? Sir? And again, so I'm here to give you confidence that for the foreseeable future, we have an advantage in this area of evaluation for a few reasons, and they all focus on our biology. We have some numbers there, 70 billion neurons and a quadrillion synapses ready at a moment's notice to evaluate choices, which is more processing power by an order of magnitude than any supercomputer in existence today. In fact, you could say it's scary to learn, but there's DARPA projects trying to create brain-machine interfaces such that we can send data into human brains because they actually can process certain things faster at a subconscious level than and sort of there's this idea of taking advantage the other way around, which is pretty wild. And the third is neuroplasticity, or the ability of the neurons in our brain to separate, reattach, and change their properties, which is pretty awesome. And it allows the brain to rewire itself. And that's something that no computer can mimic just yet. And so because this presentation has had a theme of time, I want you to imagine 70 billion neurons as 70 billion seconds. And if you do that, that gives you 2,240 years of time. So hopefully that's a little bit more relatable. I think it's really even more impressive when you hear one quadrillion. What does that number mean? Well, in the same time scale, that's 24 million years. And so this is me just trying to frame it in a different frame of reference in order to try and reinforce the fact that we're pretty dang cool as humans. All right. So given everything we just talked about with creativity, imagination, evaluation, what is the best strategy to utilize artificial intelligence and machine learning to enhance our capability as creative humans? And that's where we're going to get into this fun talk about superpowers. I think, it's not, I'm not really surprising anybody by saying, I think working in VR already is a superpower, and certainly in Gravity Sketch as well. There's really good discussion around this idea that AI and machine learning tech will be best applied in complementing and augmenting human capabilities rather than replace the need for humans, use the advantages that these technologies bring to the equation, and use them to give human superpowers. The example I give you that's hopefully very relatable is Waze. So first there were maps, and for you kids in the audience, they were printed on paper. And it's a joke because some people found it hard to fold them back up. Next came GPS, and we threw away our annoying paper maps. When you take maps plus real-time data and some AI algorithmic magic, you get an app like Waze. I'm going to paraphrase a quote from an article about this, and it says, by combining AI algorithms and real-time data, Waze can take advantage of a dynamic, ever-optimizing map to get you to your destination on the best route possible. Waze doesn't replace the driver, rather it amps up your navigation skills and collaborates with us to achieve productivity gains in navigation that have previously not been possible. I think if you used Waze and got there and didn't tell anybody, you look like a magician sometimes, the way it can help you out. And so the first example that I want to talk about for an AI-enabled superpower within Gravity Sketch would be voice recognition. And I think the devs have done a truly masterful job of adding more and more features while keeping the interface intuitive and shallow, meaning minimal menu depth, all within the constraints of the controllers that people use for VR. But I can envision a future state where I can talk to GS in a natural way in order to optimize how I use the app. And I think at first it will be simple commands like new layer or edit this or ungroup, evolving into more complex interactions that would simply not be possible within the constraints of physical VR controllers. So you can talk to Daniel, right? There's only so many buttons that you get to utilize. And so I think the idea is that it would be smart enough to pick your voice out of many in a multiplayer session. And further down the line, there could be real-time language translation. That way I can collab with anyone around the world, everyone speaking in their native tongue. Building on the idea of an AI voice assistant, it's easy to start imagining the improvements that will occur in the way people learn how to use Gravity Sketch. This idea comes straight from all my experiences of introducing people who are sometimes they're totally new to VR or they're just new to Gravity Sketch. This includes STEAM events where we share Gravity Sketch with hundreds of school kids, all the way up to sitting down with the design executives and getting them up to speed with the software. We typically have a short amount of time to explain the controllers and the basic idea of the user interface. And so every first experience is different. As you attempt to balance the available time, you have to explain things well just enough to get them excited by the potential and set the hook without leaving them feeling like they just drank water from a fire hose. And so I look forward to a future where Gravity Sketch users can learn how to use the app in a much more emergent way. In an AI assisted mode, you can imagine it recognizes that you're a new user, takes cues from how you use the app, what you're struggling with in order to decide what features or functionality it can teach you next. Natural language search for a particular tool would not only bring up that tool, but offer a new user a quick snack demonstration of how to use it. Use a learn by doing methodology, sort of show and then have you do it right there on the spot. As a sort of a evolution of the in-app videos that Gravity Sketch currently has. And being able to ask the app itself questions like, how do I do this? Or is it possible to do this or that? And that would simultaneously, or hopefully reduce the amount of questions being asked on the Discord, but could also yield data that could then be mined by the devs to improve discoverability of a particular tool. or if the tool doesn't exist, it automatically submits it as a feature request. I think for many people, the comfort of VR is something that we still need to work on, and that's many different factors, right? So being in VR for the first time, it can feel like if you put your shoes on the wrong feet. And I don't know if you've ever done that intentionally, but you should go try it, right? Just to have empathy for what VR can feel like to people if they've never tried it before. You're definitely having an experience, and it's probably interesting, but it may not just be a comfortable one. And I fully expect headsets to improve and comfort will improve and more people will get their VR legs. And my hope is that the software in combination with the hardware will sense the user's comfort levels and maybe recommend the user when they ought to be taking a break. As we all know from experience, if the HMD is not hitting target frame rates or acceptable frame rates, or dropping frames, or if it loses tracking, it can be really lead to some serious discomfort. All right, so now we get to some visuals here. What you've been staring at this whole time. The easiest application of machine learning would be as an interpolation tool. So create two different themes of wheel design and drop them into the iteration bucket. And sit back and relax while an algorithm churns out a stream of variations based on the two themes you supplied. And it really sort of takes advantage of all the things that we're good at, right? We are the ones that get to decide what are the best directions to pick. Grab some from down the line, and you grab these are put together. You could grab another one and have it go to there. Right? All kinds of mix and match. This is just meant to show a progression between a couple different themes. Why stop there? So let's use disentanglement to our advantage. Create a bold new direction for a design DNA of a vehicle DNA, and then let machine learning morph it onto a completely different package. Does the theme hold up, or does it fall apart? And there's definitely a good reason, in situations where you want your vehicles to look similar, right? That might be an advantage in time savings. Maybe you make changes to that theme and send it back to the original. Maybe it works better on your original package. Who knows? As Gravity Sketch becomes a larger part of design students' toolkit, something I'd like to see in the future, in near future, is a way for students to share their design work in new ways. This shift in mindset comes from what we learned in our first ever virtual summer interns, thanks again to COVID. The persistence of their co-sketch room was leveraged to be able to show the entire arc of the creation of their designs through all phases of the project. And so I think if you set the ground rules at the beginning of a project, say, look, don't delete everything, and you get a timeline aspect, sort of building along the mirror plane is something we see a ton of in car design. It allows the designer to show the shiny finished design at the end, but also all the steps it took to get there, which as someone who might be evaluating somebody for a job, that's really valuable. So maybe it's a standalone executable that can be easily shared, and since it could contain the entire design progression, it gives you this ability to evaluate how the student thinks through their design, and be better able to evaluate the choices they made along the way. I've done one session of this already, reviewing a student portfolio project in VR, and it was tremendous. And I look forward to more VR portfolio reviews in the future. All right, so I see Jaren is messing with the wheels, so let's get to the next one. Design together. So one last idea regarding future workflows comes back to this notion that we should be having fun doing what we do. I think that's maybe one of the best things about designing VR is it really does just feel like fun. And that's not a bad thing, right? So if your bosses are listening, it's actually a really good thing to be having fun. And CoSketch will continue to allow for collaboration across different skill disciplines that have traditionally been kept siloed. Thankfully, that will continue. Part of being a better human is to seek to understand others' viewpoints, and at the very least, gain some empathy for what they have to do in their line of work. Back when I was working on a redesign of a Ford Super Duty truck, which it's, for comparison purposes, the one that's bigger than the F-150, which is considered a full-size truck. We were told by an engineer that the change we were asking for was going to be felt by the person on the assembly line being asked to hold this part over their head during assembly. And at the time, I found it really hard to relate the concept to myself, except to think, why that would really suck, I guess. But now we have the ability to create new concepts much faster than before. And maybe we can take some of that time back to make more to be more holistic in our designing. An example I have here is screenshots from this game that I've been playing. It's a mechanic simulator called Wrench, and it's in VR. It's kind of really wild and amazing. And it's got me thinking about the power of having fun while, quote unquote, playing the game of design. And I started to do some sketching over the screenshot and some modeling of surfaces. I can imagine a mashup of engineering and design, this wrench sim and gravity sketch, and this idea of designing not in isolation, but with everyone who's needed to make the product successful over its entire life cycle. Design for the customer, sure, they're first. Design for assembly, design for disassembly, design for recycling. Right? There's now that we can do this so much faster, let's do it better. And I guess the last parting thought as I wind down here is, there's this increasing emphasis on experiential design and or designing customer experiences and designing the customer experience for when they use the product or service. And there's a Disney Imagineer I follow on Instagram. His name is Joe Rohde. You should follow him too. Rohde. And I'm going to paraphrase from a recent post he put up on Instagram. And basically, it's if you want to design experiences, you have to go and have those experiences. And this sounds like a no-brainer. I get it. My hope is that the shift in the way that we've worked at Ford over the past many months evolves into a more deeply integrated hybrid way of working that is a shift not just in response to a crisis, but one that balances getting the job done and getting out into the world to gather more experiences. And if you get any reasons, just tell your bosses you're trying to stay ahead of the robots. And that is the end. So I'll turn everything back on.
Awesome. Great, Michael. Thank you for the really, really well-crafted presentation. There's already some comments around, fascinating stuff. I love the way that you have used Gravity Sketch as a presentation tool. Great job. So yeah, it's an amazing presentation. Do we have any questions from the audience? I think I see a lot of claps, amazing presentations, and so on. Not too many questions. If not, I'll just start jumping into asking questions myself. Cool. All right. Well, you mentioned something really important, and I think we have heard it throughout the different talks yesterday and today, which is having fun. And I especially like how you talk about this because you know how important it is. But can you kind of go a bit deeper into that? Why do you think having fun is important for doing design work at a large car manufacturer?
Well, I think what it comes down to is it goes back to the beginning, right? Talking about subconscious. If you're not having fun, then your brain is actually distracted by other stuff, right? And so this concept of it, and I've had to fight. Murray Callum was my design VP during the time of bringing Gravity Sketch on, and I went at it with him about this phrase of having fun. Playing design. He took great umbrage at that at the time. I convinced him. I think otherwise by the end. It's this idea that there's a stigma about having fun while you're doing stuff. So I think that's what I'm trying to get at is this idea that institutionally speaking, we need to get over that notion that if you're having fun, you can't possibly be doing work. And I think that's the problem, right? And I think it's kind of a sneaky way, because if you just use Gravity Sketch, you're in CoSketch, you're probably going to be having fun, and so you don't have to tell anybody that you're having too much fun.
Yeah, it's kind of like a weird one, because if you think about it, design is a passion job, right? We all go into design because we love it, right? We have fun. We do it as a hobby almost. And the fact that somehow it is expected that for you not to have fun at your place of work? I mean, it's not expected that you don't have fun, but it's kind of like frowned upon that you are having fun.
Yeah, and I think, what you say about passion, right, is this inability to turn it off. And I think again, to get into that sort of conscious intent to daydream, right, is that you're basically enabling the switch to be on more than it's turned off, right? I keep trying to use the phrase gravity napkin sketch, but it doesn't, it's still too fussy. But this idea of, in that timeline, we are literally at an eighth of an inch, right, into the progress of this tool as something different than before. So, holy crap, we got a long way to go and a lot of fun to be had in figuring out how to use it best. And I think if it just feels like a job and isn't tapping into your subconscious creativity, then it's no good. But I think we're in good shape here.
Yeah. And there's like the last point that you touched on, like in order to actually design experiences, and you are designing experiences, right? And I think you are designing experiences more and more as kind of like the automotive industry shifts into a different way of understanding vehicles. And so the fact that you're actually inside of the experiences, like inside of those environments, how is that affecting how you think about your design process?
Yeah, I think, and again, it goes back to the very beginning. The thing that sold my management on it was when I told them that I had started with me in a seated position and that I designed the car around myself. I think that was the beginning of the whole progression of why we need to get in this. And it's for exactly that reason, right? If you're trying to gain empathy for your customer, what better way to do that than to literally sit in their seat, right? I've said this before, but putting the VR headset on and designing inside VR is in fact becoming the customer. You're allowed to think like them. And again, I'm not going to get into PhD level stuff, but there's something special going on in your brain when you can have conscious and subconscious sort of working together, because VR allows you to sort of separate yourself. And Joe Rohde actually has some more cool talks about experiential design and how it's accepted that you're playing, right? Everybody accepts that you're playing, and it allows you to, he calls it relax into the immersion. And I just love that phrase. VR by its nature, because it's putting a headset on and going somewhere virtual, you're sort of establishing a new rule set. And by doing so, that relaxing into the immersion of it, I think is definitely easier and more impactful.
And in a way, it's abstracting your mind, right? Like it's just kind of like abstracting it into a focused state that allows you to just kind of like really think about the thing that you're working on.
I'm gonna spell it out. So there was somebody in chat was asking how is his name spelled, and it's Joe, Joe, and his last name is Rohde, Rohde. Yeah, go find him on Instagram.
Yeah.
It's tremendous.
Joe Rohde. Oh, you can type it on the chat, Michael.
Yeah, okay. So if I say to everyone, I was, I'll learn how to do this Zoom thing here in a second. It's Joe.
Great. Well, I mean, the last question that I have for you is how, because you spoke a lot about, I mean, you can, obviously you touched on the collaborative aspect of it, right? But right now in the conversations that we've been having, we're talking about having fun, which is kind of like something individual. We're talking about like being immersed in an experience that allows you to, create different experiences and designs. But how, like, removing all of that, removing all of the creation aspect of VR and Gravity Sketch, how do you think it's actually kind of like informing your design process in the communication aspect of things?
Well, that definitely gets into the last part where, talking about designing together. And I recognize that, saying designing together is better than designing separately. I know that we have designed together in the past. I think what we're exploring at Forward in terms of the virtualization of the process is, what parts can we virtualize with, very little, I don't say damage, but, very little interruption to the processes that already work, and what parts are going to cause trouble, right? I think there's sort of, you have to be really sort of realistic about taking a healthy approximation or an appraisal of a situation and say, gosh, we'd really like to do more work together. Well, some of it's going to be technical in terms of limitations. There's data sets that the engineering folks work with that are really massive, and we have to do lots of massaging to pull them nicely into Gravity Sketch. It's also sociological, or we have a way of equipping our staff with VR, and the rest of the company is not. They're sort of, the future is not equally distributed, and so again, that notion of where we are on a time frame of humanity, and where we are in terms of the technology of VR and its implementation. I'm comfortable being uncomfortable with how there's a little bit of a lag right now, right? It's just the way the world works sometimes, that the future is just not equally distributed. And so, things like you guys collab for everyone, and the fact that headsets are becoming lower price points such that more people can get into them. It's making it way more approachable, and it's only going to help to build this sort of larger user base that we know will then come to school and be native to VR, where I'm not going to have to be there saying, hey, don't you want a headset? It will just be assumed, right? That will be the default toolkit, if that makes sense.
Awesome. Cool. All right, Michael. Well, thank you so much for your presentation. The VR head, hair, and mask also. Cool. All right. Well, thank you so much.